Hello, my name is Mr. Asprey and this is 2024 EDEXCEL AS Pure. And if you like my content and you think it's helpful, then please do subscribe and let's get into the maths. Okay, question number 1, and we are integrating. Now when we integrate, we want all of our terms to be just coefficient x and then to the power of n. At the moment we've got this fraction which isn't particularly helpful for integrating, so we need to rewrite it. So what I'm going to do is I'm going to do integral sign, and then we're going to write on top we've got 2, and this square root of x is the same as x to the power of a half, and then we're going to divide that term by x squared, and then also on the numerator we've got a minus 3, so we're going to write minus 3, and we need to divide that term as well by x squared. So we've just split up that fraction, and then we need to integrate all of that with respect to x. Okay, so let's carry on. So what we've got here is we've got 2 on the numerator, so we've got 2, and then we have x to the half divided by x squared. So when we divide x's, we subtract the powers, so a half minus 2 is x to the minus 3 over 2, or minus 1.5. And then here we've just got minus 3 on the numerator, and then we've got x squared, but that's on the denominator, so we can represent that by x to the minus 2. So the negative power means that whatever the x is on the denominator. Okay, great. Now we're going to integrate that with respect to x. Okay, so now we can just do our standard integrating, which is up the power, so add 1 to the power, which gives us minus a half, and then divide by that new power of minus a half. And then here we need up the power by 1, so adding 1 to the power gives us minus 1, and then we divide by the new power, which is minus 1, and then once you've integrated we always need to add on that plus c, the constant of integration. Okay, so now we can just evaluate this. So 2 divided by minus a half is minus 4, and we can just leave the power like that, and then minus 3 divided by minus 1 is plus 3, and we can just leave it like that, and then plus c, and this will be our final answer. Perfect. Okay, question number 2, and we've got a function f of x is equal to this with some missing terms in it, because we've got a and b are constants, but we know that x minus 4 is a factor of f of x, so use the factor theorem to show that. So if x minus 4 is a factor of f of x, then we know that f of 4 is equal to 0. Okay, so that's just your standard factor theorem rule. If x minus a is a factor, then f of a equals 0, and vice versa. Okay, so all we need to do is just substitute 4 into the function, and then set it equal to 0. So f of 4 would be 2 lots of 4 cubed minus 3 lots of a multiplied by 4 squared plus b times 4, so 4b, and 8a, and all of that equals 0. Okay, let's evaluate this. So 4 cubed is 64, times 2 is 128, minus 4 squared is 16, times 3 is 48, plus 4b plus 8a equals 0. Let's collect up like terms. So we have 128, and the number of a's is minus 40, and then plus 4b equals 0. And then let's just double check how they want it. They want 10a on one side and the rest on the other. So divide by 4 is going to give 32 minus 10a plus b equals 0, and then just move the 10a to that side, so that will be positive 10a, and then we'll be left with 32 plus b on the other side. So just moving that 10a to that side, and then just writing it the other way around. Okay, great. Okay, part B says given also that x minus 2 is a factor of f of x, express f of x in this form, where k is a constant to be found. So a bit of a strange question this, because it looks like we're going to be doing exactly the same skill again, and that is just subbing in this time 2 and setting that equal to 0. And that's going to give us another equation in terms of a and b, which we can solve simultaneously to find the values of a and b. Okay, so we need that function back here, so let's just plonk it here, and then let's do f of 2 this time, which would give us 2 lots of 2 cubed minus 3 lots of a 2 squared plus 2b plus 8a is equal to 0. So just subbing in 2 there. Right, what's this going to give us then? So that is 16 minus 4 times 3 is 12 plus 2b plus 8a is equal to 0. Okay, so that is the same as 16, and then we have minus 4a plus 2b equals 0, and we're going to divide through by 2 to get 8 minus 2a plus b equals 0, and then we're just going to write it in a similar way to that one, which is I'm going to write 2a on that side, and then that's going to be 8 plus b on that side. Okay, so that's going to be useful because it means we can solve simultaneously this one and the purple one. So let's just write them one above the other. So that one and then this one. Whoops, that should be 32 plus b. And that's 8 plus b. And then we can subtract them in order to cancel out the b's. So that's going to give us 8a is equal to 24. So a is equal to 3. Okay, and then once we've got a, we can then find b, relatively straightforward. Just by looking at this one here, if a is 3, then that makes 6. 6 is equal to 8 plus b, so b must equal 2. Okay, so now what we can do is we can actually rewrite the function. So the function, which we can still see there at the top of the screen, is now f of x is equal to 2x cubed minus a, we said is 3, so 3 times 3 is 9, so that's 9x squared. B is 2, so plus 2x, and then a is 3, so that means plus 24. Okay, great. Now we already know 2 factors of this, so we know that we could split it up into its factors, and one of the factors was minus 2, x minus 2, and the other one was x minus 4. So the question is, what is the third linear factor? Now there has to be 3 linear factors. Well, technically that's not true, but it's a cubic, so it has a maximum of 3 linear factors. And the question actually already tells us that it will be possible to split it up into 3 linear factors. So it's safe to assume that this has exactly 3 linear factors. And you can actually already see that 2x has to go in the bracket which we need to find. So 2x needs to go here. Now, what's going to make all the difference here is this term here, the constant term at the end. When we expand out linear factors, then the constant term will be all 3 of these terms multiplied together. So minus 2 times minus 4 times something must equal 24. So minus 4 times, so minus 2 times minus 4 times by whatever this k value is, we're told this was going to be some number we need to find, that will equal 24. So solving this gives us 8k is equal to 24, so k must equal 3. So we can write it out in full as x minus 2, x minus 4, 2k plus 3 for our final answer. Whoops. Okay, that'll do. Alright. Now it says, hence state the number of real roots to the equation. Well, we know that it has 3 linear factors, so therefore it will have 3 real roots. So the answer to this one is just simply 3. It says write down the largest root of the equation f of a third x is equal to 0. Well, f of a third x means that we replace all the x's with a third x. So let's go down and let's do that. So for part D, f of 1/3 x, it basically means we swap out all the x's for a third x, like so. So 2x will be 2/3 x plus 3. Now, where's the largest solution going to come if we want to set this equal to 0? Well, it's going to come from this bracket here, and you can check yourself about all the other ones as well. But I can tell you it's going to come from this one, and that's going to equal 0. So third x will equal 4, so x will equal 12. So that's the largest root. And of course, if you would have solved the other brackets equal to 0, well, this one here you would get a negative answer, and this one here you would end up with 6. You'd have 2 times 3, which is 6. So 12 is the answer. Question 3. Relative to a fixed origin, point P has a position vector, blah blah blah, and Q is that one. Find P to Q. Okay, so the fundamental equation for vectors is that if you want to go from P to Q, you go from the origin to Q minus the origin to P. So let's do that then. So O to Q we know is 3i minus 5j. O to P is 9i minus 8j. So 3i minus 9i is minus 6i. And minus 5j minus 8j is the same as minus 5 plus 8, which is plus 3. Okay, great. That's that done. It says, given that R is the point such that Q to R is equal to this, show that that angle is 90 degrees. Okay, that's interesting. Well, one could do this in a couple of ways. You could either look at gradients, which I think we will do because it would be the simplest, or you could look at distances. You could create a triangle and show that by Pythagoras it must be a right angle triangle, but I think that will take a bit longer. So let's imagine what we've got here. So we've got P, we've got Q, and we've got R, and we know that it's going to be 90 degrees. So P, Q, and R. So once again, what you could do is you could just work out the distances of each of those distances, and you should be able to show that by Pythagoras that's going to be a right angle triangle. But we're not going to do that actually. What we're going to do is we're going to work out the so the gradient of P to Q is just simply the j coefficient divided by the I coefficient, because j is going up, I is going to the side, so the gradient is changing y over changing x, so the vertical, so P to Q is the vertical is 3, and then over the horizontal is minus 6, so that gives us a total of minus a half. Okay, now if we can work out Q to R, oh, we don't need to, we already have it. We just need to work out the gradient of Q to R then. So the gradient of QR is the horizontal, which is 18, sorry, the vertical, which is 18, over the horizontal, which is 9, and that gives us 2. Okay, so we can say in conclusion, because we always need to write a conclusion, so important, as minus a half times by 2 is equal to minus 1, P, Q, and QR are perpendicular, hence PQR is equal to 90 degrees. Perfect. Okay, part C. Given also that S is the point such that PS is equal to 3QR, find the exact area of PQRS. Okay, well, once again, there's 4 marks, so we've got a bit of work to do here. And it's a good idea to draw a diagram. Now, in fact, we already have this little diagram here. So I'm just going to move that down. We're going to use that again, but this time we don't need to connect up PR. But what do we need? We need S in there to create a shape. So so P to S is equal to 3 lots of QR. So QR is this down here. So if we times that by 3, we get PS. So Q to R is in that direction. So PS is going to be looking like this. It'll be 3 times bigger than QR, but it has the same direction. Okay, so what we look like we've got then is we've got a trapezium. So that's S, and then that right there we can connect up. Okay, great. So if we have a trapezium, we could use the area for trapezium. So the first thing we want to do is we want to work out the distance of Q to R. Now Q to R, we already know what that is because we were given that. Q to R is 918. So the distance of a vector is the sum of the squares of their components. So we can do that. We can get the calculator pop in for the first time. So that is the square root of 9 squared plus 18 squared, and that's 9 root 5. Okay, great. Alright, so let's put that on the diagram. That's 9 root 5. Now we know that PS is 3 times that, so if we times that by 3, that's 27 root 5 up there. So now, in order to use the area of a trapezium, we just need to do the distance in between the 2 parallel sides. So we need PQ. We need the distance of PQ. So what is PQ? We worked that out here. PQ in this purple box. So minus 6 and 3 are the 2 components. So the distance is the square root of the 2 components squared and added together. So again, we can get the calculator pop in again. So 6 squared is the same as minus 6 squared, so it just saves time to put in 6 squared. And we get 3 root 5. Okay, great. So we know that that is 3 root 5 there. Okay, so what we can do now is we can use the formula for the area of a trapezium. And the area of a trapezium, an easy way to remember this, it's half of the 2 parallel sides added together. So the 2 parallel sides are 9 root 5 and 27 root 5, and then times by the gap between them, which is 3 root 5. Okay, so let's just simplify this a bit. So 9 plus 27 is 36, so it's 36 root 5. Whoops. 36 root 5 times by 3 root 5. A half times 36 is 18, so 18 root 5 times 3 root 5. And 18 times 3 is 54, and root 5 times root 5 is 5. So it's 5 times 54, which is 270. Brilliant. Job done. Question 4, and we've got a triangle and a triangle. We've got loads of information, but I think all of it is just on the diagram, and it says show that x is equal to 10.5, correct to 3 significant figures. Okay, so we need to find a triangle really that has as much information in it as possible. So to me, that would look very much like the triangle here, which is BDC, because it has quite a lot of information. In fact, what it does have is it has a side with the angle opposite it, and it has another side with the angle opposite that, which means we can use the sine rule on that triangle. So let's do that then. So let's use the sine rule. So we want to find the side, so we're going to put the x's on top, the sides on top. So we have x over the sine of the angle opposite it, and that is equal to the other pair, which is x plus 3 over sine of the angle opposite that, which is 140. Okay, so now let's scroll down and use and solve this. Okay, I'm going to solve this, and I'm also going to try and keep it as exact as possible. So the first one I'm going to do is cross multiply the sines up to either side. So this is going to give us x lots of sine 140 is equal to x plus 3 lots of sine 30. Okay, so we've got x sine 140, and then multiplying out this bracket gives us x sine 30 plus 3 sine 30. Now we've got two x's here, so let's move them to the same side. So x sine 140 minus x sine 30 is equal to 3 sine 30. That allows us to factorise here, like so, and then we can divide by that factor. Now you may say, like, why not just use your calculator here? Well, yes, sure, but I want to be as exact as possible with my working, and there may be questions where they do ask you to give things in exact form. So that is the exact answer for x. So now I'm going to use my calculator to work out what the rounded value is. So I'm going to do a fraction. I'm going to also need to make sure that my calculator is in degree mode. Do 3 sine 30, and we're going to go over sine 140 minus sine 30, and that just leaves the working nice and neat, no horrible decimals, and then there we go, there's our answer. So we can say that is equal to 10.5. In fact, we can say that's approximately equal to. And that's exactly what we were told to show. Okay, brilliant. Next it says, given also that AD is x minus 2, find the length of AB, giving your answer to 3 significant figures. Okay, so we need to have a look at the diagram. It says find the length of AB. Okay, so now we're going to clearly be looking at the larger triangle, this triangle here. Like that, because we know this, and we know this, and we also know this angle, because angles on a straight line add up to 180, so that must be 150, and then this is the angle, this is the side that we're trying to find. So we've got two sides that we know with the angle in between them, and we're trying to find the side opposite that angle, so this is classic cosine law. Okay, so for the cosine rule, again I'm just going to write it out. A squared is equal to b squared plus c squared minus 2bc cosine capital A. So the angle which we were looking at was 150. The two sides that flank the angle were x minus 2 and x plus 3. Okay, good. And x plus 3. So x minus 2, well, x is 10.5, so that will be 8.5. And for this one, plus 3, that will be 13.5. Okay, so we should be good to go. So AB is the side length that we're looking for. We can square root to get this on its own, and then b squared is going to be 8.5 squared. C squared is 13.5 squared, minus 2 lots of 8.5 times 13.5 times by cosine of 150. Okay, perfect. Okay, so that's just going to go into our calculator. Okay, I've just subbed that in directly, and we've got an answer of 21.2897. And okay, and that is approximately 21.3, and this was all in centimeters, so we must give the units because we've been asked to work out a distance. Just quickly, interestingly, so this one we need to give units. X we didn't need to give units, and that's because x is a value. It's not actually the distance. X is actually a value, whereas we're looking for the length of AB, which is a distance. Question 5, and we've got a curve with this equation, and it says sketch, stating the coordinates of any points where the curve cuts the axis, and then state also the asymptotes. Okay, so let's just put the curve here so we can see it, and then we're going to draw a coordinate axis, nice and large, like so, and any graph, reciprocal graph, which is some constant k divided by x, is always going to have the same shape. K doesn't really change the shape at all of the graph, so it's always going to have the same shape. So a reciprocal graph is going to start over here, it's going to hug the axes, and it's going to bend around and then hug this axis here, and then it's going to carry on up here, it's going to bend around, and it's going to hug this axis down here like that. Pretty good. I'm really happy with that actually. That is pretty good reciprocal graph, as you can do on a pad like this. Okay, now, so the 6 doesn't really doesn't change the shape of the graph really at all, but the plus 3, that does. So that transforms the graph. So at the moment, the asymptotes are the lines where the graph does not cross, are here and here. They're in fact the coordinate axes. But if we are to plus 3 to the graph, it's going to transform the graph. So this is going to move up by 3, and this is also going to move up by 3. So the whole graph is going to be shifted up by 3, like so. Okay, and that also means that the asymptote is also going to shift up by 3. So that is now the new asymptote, like that. Okay, now for asymptotes we normally draw dotted lines. So I'll just draw a dotted line like this to represent the horizontal asymptote, like so. Okay, perfect. Whoops, this one's not going to change at all. Okay, so this horizontal asymptote is now y is equal to 3, because before it was the x-axis, which is y is equal to 0, but because it's been shifted up by 3, it's now y is equal to 3. Okay, now there is one intersection, isn't there? There's one intersection right here. Okay, so where is that intersection? Well, that is intersecting the x-axis, so we set y equal to 0 in order to solve for that intersection. So we set y equal to 0, and then we minus 3 to both sides, times both sides by x, and divide both sides by minus 3. So 6 over minus 3 is minus 2. So that happens at minus 2, 0, that intersection. And the final thing to do is to label the vertical asymptote. So just go to a dotted line like that, and that is x equals 0. And we're done. We've got the two asymptotes, we've got the point of intersection, all labelled nice and clearly. Lovely. Okay, part B, it says show that the curve C2 has this equation, and it says show that C1 and C2 intersect, we get this equation here. Okay, so when two curves intersect, then we can solve simultaneously, and then that will allow us to get an equation for the intersection points, which is this one. Now, in order to solve these two simultaneously, the easiest way to do that is to set them equal to each other, because they are both equal to y. So we can set them equal to each other. And I will do that now. Equal to y, so let's just set them equal to each other. So we're going to do 6 over x plus 3 is equal to 3x squared minus 4x minus 10. Okay, now the first obvious thing to do would be to multiply through by x, which cancels the x on the bottom here, so we're left with just 6. Don't forget we've also got to times this term by x as well, so that's 3x, and then we get 3x cubed minus 4x squared minus 10x. And now let's bring it all over to one side. 3x cubed minus 4x squared, and then minus the 3x gives minus 13x, and then minus the 6 gives us minus 6. Okay, so that should be our equation that we need to solve in order to find the intersection points of those two curves. Okay, it then says, given that the x-coordinate of one of the points of intersection is minus 2 over 3, use algebra to find the x-coordinates of the other points of intersection. Okay, so if a solution to this equation is x equal to minus 2 over 3, then we can actually work out what one of the factors is. And I'm going to show you right now how we can do that. Okay, so we know that x is equal to minus 2 over 3 is a solution. Now if we can change this equation so that it equals 0, then we'll be able to find out one of the factors. So I'm going to times through by 3, and I'm going to add 2, and this means that x, so 3x plus 2 is a factor. Okay, so what that allows us to do then is to divide this polynomial by 3x plus 2, and that's going to give us the quadratic factor, and then after that we can find the two linear factors and thus the two other points of intersection. Okay, so polynomial division. We take the lead term, which is 3x cubed, and we divide it by the lead term of the divisor, which is 3x, and this gives us just x squared, and then we multiply x squared by the 3x plus 2, and we write that below. So this is going to be 3x cubed and then plus 2x squared, and then we're going to subtract. Now the 3x cubed minus the 3x cubed goes to 0, minus 4x squared goes minus 2x squared gives minus 6x squared, and then these terms here come down as well. Then we do the same thing, we look at the lead term, which is this, and we divide it by 3x, and that gives minus 2x. Yep, that's right. And then over here we do minus 2x and we multiply it by 3x plus 2. So that gives minus 6x squared, and then minus 2x times 2 is minus 4x. Draw a line under and we subtract. So minus 13 minus minus 4 is minus 9. And then we do one more time. That's the lead term, so we divide it by 3x, and that gives us minus 3. So therefore we do minus 3 times by 3x plus 2, and if it's a perfect factor we should get 0, which is exactly what we get when we subtract the final row. Okay, great. So this purple box now can be written as 3x plus 2 x squared minus 2x minus 3 equals 0. And remember, this purple box is the equation which gives us the intersection points. So we can factorize this once more because quadratic factorization is relatively straightforward. We got minus 3 and plus 1. because we're looking for two numbers that times to make minus 3 and add to make minus 2, and that is minus 3 and plus 1. Okay, so this tells us that one of the solutions is this, equal to 0, which gives us x equals minus 2 over 3, but we knew that already, of course. We knew that from up here, and that is in fact what started this whole party off. So we know that one. This next one, x equals 3, that comes from this bracket here, and this bracket here must be x equals minus 1 in order to make those brackets 0. Now, does it ask for the overall coordinates or just the x coordinates? It says use algebra to find the x coordinates. Okay, so we're good. We don't need to sub back into one of the equations to get the corresponding y. These are just our two final answers. Brilliant. Question 6, the binomial expansion of 1 plus ax to the 12 up to including the term in x squared is given as this, where a and k are constants. Okay, so we just need to expand it out basically, then compare it to what they've given us in order to work out what the constant a is. So the first thing to spot is that the power of the bracket is 12. So our value for n is going to be 12. So that means that we're going to use 12 and then choose 0 is where we start. And we've got two terms, so it's a binomial expansion, so two terms inside the bracket as always. So we're going to take the green term here, which is ax, and we're going to raise that to the power 0, and that means the other term, the yellow one, is going to be raised to the power 12, because the two numbers, the two powers must always add to make overall the value of n. And then the next one will be 12 choose 1, and we'll take the green and raise it to the power 1, and then the yellow will be raised to the power 11, and it's just going to continue on like this. So 12 choose 2, green goes up to power 2, and the 1 goes down to power 10. And of course we could carry this on all the way, but we don't need to, because we just need to go up to the x squared term, and this is going to give us the x squared term here. Okay, so that tells us that, well, 1 plus a to the x, sorry, 1 plus ax to the 12 is equal to, okay, so without using the calculator, I know that 12 choose 0 is 1. I know anything to the power 0 is 1. I know 1 to the power of anything is 1, so times them all together, we get 1. Well, hey. I also know that 12 choose 1, anything choose 1 is always what that thing is, so in this case it's 12, so that is 12. Ax to the 1 is just ax, and then times that by 1 to the 11 is timesing it by 1, so no need to put that. Okay, now 12 choose 2, without doing a quick calculation, I'm not sure what that is, so watch me spend the next 2 or 3 minutes trying to find the choose function on this new calculator. Okay, I found it. So we want 12 choose 2. 66. Probably could have worked that out quicker, but anyhow. 66. Okay, so that's 66, and then we are timesing that by ax squared. Now this is a big mistake people make. They forget to square the a as well as the x, but this is a squared, x squared, and then times by 1 to the 10 is just times it by 1. Okay, great. And we also know that's equal to this, so we can set it equal to this, 1 minus 15 over 2x plus kx squared. Okay, great. Now we can compare coefficients. So the number of x's in our expansion needs to match up with the number of x's that we're told is in the expansion. So therefore we can say that 12a must equal minus 15 over 2. Great, so divide by 12 gives us minus 15 over 24, which simplifies down to minus 5 over 8 for our value of A. Okay, that's helpful. Now on to B. It says hence find the value of K. Well, we can again use the expansion. Now the x squareds must match up. So that tells us that 66a squared must equal K. So K is equal to 66 and a squared will be minus 5 over 8 squared. Great. So we can do 66 multiplied by 5 over 8 squared is the same as minus 5 over 8 squared. So just save us some time. Just put that in. Okay, great. So that is K is equal to 825 over 32. And that will be our final answer for that part of the question. Okay, great. Now part C. It says, using the expansion and making your method clear, find an estimate for the value of 17 over 16 to the power 12. Give your answer to 4 decimal places. Okay, so we have an expansion for this guy right here. And if we want to use it to work out this guy, then it means that, well, both of them to the power 12, which is extremely helpful. So it means inside the bracket must be the same. So let's set 1 plus ax equal to 17 over 16. Okay, because if we want 1 plus ax to the power 12 to equal 17 over 16 to the power 12, then we need 1 plus ax to equal 17 over 16, which means that we need ax to equal, if we subtract 1 from that, we get 1 over 16. And a, of course, we know what a is, don't we? We know that a is minus 5 over 8. So times both sides by 8, give us this. So then divide both sides by minus 5, gives us minus a tenth, or minus 0.1. So that value of x will give us this expression, this 17 over 16 to the power 12. So if we sub in an x value into our expansion, which remember is a representation of 1 plus ax to the 12, then we should be good to go. So this is what the expansion is. So it's 1 minus 15 over 12 over 2 x, which we're going to sub in, plus k, which is this, x squared, which is this. Okay, so that is definitely a calculator jobby. So we'll do 1 minus 15 over 2 times by minus 0.1 plus 825 over 32 times by, I better put that in brackets, because when we square a negative like that, I want to make sure that we get the correct answer. Okay, great. Now it asks us actually for it to a certain degree, decimal degree. So let's go back and figure out, it says 4 decimal places. So it is 2.008. That's not 4 decimal places, is it? No, it's 78. Question 7, and we are, looks like log modelling. Chimney emits smoke particles, particularly the day concentrated smoke particles in the air emitted by this chimney, p parts per million. Okay, so that's useful. Units are useful. Always highlight units. Is measured at various distances. Yeah, x kilometers from the chimney. Okay, shows a sketch of the linear relationship between log p and x, and it's used to model this situation. Okay, so we've got 2 points, which means we can work out the gradient and the intercept, which is the two things that we need in order to work out the constants of an equation like so. Okay, so the first thing I want to do is what I do with all of these log questions is I always want to split up the equation that's given using log rules. So we're going to say log base 10, because this is the base which they're using. You can see here base 10. I'm just going to write log for now. I'm not going to bother writing base 10 every time. And then we're going to log both sides like that. And then we're going to split this up, because when we have log of two things times together, it's the same as log of them separately added together like that. And then the other log rule is that if we have log of something to the power of something, we can write that as the power multiplied by log of that something. Okay, and then the final thing I want to do here is I'm going to want to just write log p here, and then I'm going to want to write it just written this way around, so log b x plus log a at the end like that. The reason why I do this is because now we can compare it to a straight line. So the two variables that are plotted are log p and x. So if I just highlight those, log p and x, and if I write below the classic formula for a straight line like so, then the two variables on a straight line are y and x, and we can see these match up to the variables on our log equation here, because what that allows us to do now is see that this must be the same as m, which of course is the gradient. So I know that the gradient is going to equal log, again base 10 of b, and also we can see here that c on a straight line, which is the y-intercept, so the intercept is going to equal log base 10 of a. Okay, so all we need to do now is find the gradient and intercept, and then we've got an equation which links them to a and b, so we can find a and b. Okay, so the gradient, let's just do that here. The gradient, m, between 2 points is y2, so this one, minus y1, so this one, over x2 minus x1, like so. So we can just quickly do that. So that is 2.1 minus 3.3, and then we need to divide that by 6 over 0, so just divide that by 6, so minus a fifth. Okay, great. So the gradient is minus 0.5. We know that's equal to log base 10 of b. So rewriting this using writing that equation in terms of an indice relationship, the base is 10, the power is minus 0.5, and that is going to equal b. Okay, so that actually needs to go into our calculator, so we'll just do that. We will go 10 to the power of the previous answer, and we get this, and that needs to be to 4 significant figures, so b is equal to 0.6309, but that rounds up, so it's actually 10. Okay, and that is our b value. Okay, so just in case you're a bit confused about how I've gone from this line to that line, well, the kind of fundamental theorem for logs is that if you have log base a of x is equal to n, then that's the same as writing a to the power n is equal to x. So these two things are equivalent, so go to logs into indices. If we just remember this, then we should be good. Okay, next, the intercept. Well, the intercept clearly shown on the graph is 3.3. So we're going to use that. So we're going to say that 3.3 is equal to log base 10a. So using again this formula here, the base is 10, the power is 3.3, and that will equal a. So on our calculator we'll need to do that. So we'll do 10 to the power of 3.3, and we will get 1995. Okay, so there we go. That's the 4 significant figures. So that's all good. So box that up, and there are our 2 answers. Okay, that was part A. Oh no, part A actually says find a complete equation. So that's not good. We need to actually write it out as the equation. So we need to put in the A and B into the equation to get the final answer. So it was P is equal to A multiplied by B to the power of X. That is in fact our final answer. Okay, great. Now it says, with reference to the model, interpret the value of AB. Okay, tricky this. So what you might notice, you might recognize this kind of equation, that kind of format, as compound interest from GCSE. So you've got the initial investment times by the multiplier to the power of the number of years, and that's exactly what this is. But we're not talking about money here. What we're talking about is smoke particles per million, and then X is the various is the distance from the chimney. So the A value is the initial amount of smoke particles when you are literally 0 kilometers away from the chimney. So AB, so remember this is the formula like this. So when X equals 0, we just get P is equal to A, because B to the 0 is 1. So we get the amount of smoke when we are literally no kilometers away from the chimney will be this parts per million. But when X is equal to 1, then we get P is equal to AB to the 1, which is just the same as AB, which is what we're trying to work out. So what is this value? Well, it doesn't really matter what the value is. I mean, we would find it by doing this multiplied by this to the power 1. But what it actually means, interpreting it, is it's the amount of smoke particles per million when we are 1 kilometer away from the chimney. Okay, so there it is. There's the answer. So it's the concentration, again, of smoke particles in parts per million when you are 1 kilometer from the chimney. Question 8, and it's quite beastly, this one. We have a cubic graph. We've got a straight line. We've got points A and B, and we've got a region that has been shaded. Okay, so we've got the cubic equation, and the line L is tangent to the point A. Okay, and given that L has this equation, show using calculus that the x coordinate of A is 2. Okay, so it doesn't say that A is a minimum point, so we don't know that. But what we do know about A, because we know the tangent is this at A, we know therefore the gradient at A, so the dy by dx at the point A must equal the same gradient as the tangent line, so it must equal -2. So that is what we're going to use, and that is why it says using calculus. Okay, so part A. We know that y is equal to x cubed minus 14x plus 23. So that's the equation of the quartic, of the cubic. So when we differentiate it, we get 3x squared. The 3 comes down, times by the coefficient of 1 to make 3. Drop the power down by 1 to make 2. This is 14x to the 1, so the 1 comes down, times by the minus 14 to make minus 14. Drop the x power down by 1. And x to the 0 is just 1, so times it by 1, we don't need to bother writing it. And then 23 is constant, so you could write it as 23x to the 0. 0 comes down, times by the 23, makes 0, so any constant differentiates to 0. So that's dy by dx of the cubic curve, and we want to know, or we're told that at the point A, this dy by dx is equal to minus 2, because the tangent has a gradient of minus 2 at that point. So we can say 3x squared, if we add the 14 to that side, that gives us 12, so we get x squared is equal to 4, so x is equal to plus minus 2. But we have to use our knowledge of the curve here, and we can clearly see that A is in the positive quadrant, so the x coordinate must be positive. So we can say that as A is in the positive first quadrant, x equals 2. Perfect. Okay, part B. It says the line L cuts C again at the point B. Verify that the x coordinate of B is equal to minus 4. Okay, well, we need to find an intersection equation where this and this intersect, and then we need to show that B is a solution to that. So where do these two line and curve intersect? Well, we can set them equal to each other because they're both equal to y, and that will give us our intersection equation. So let's do that. So we're going to say that the the cubic, which is x cubed minus 14x plus 23, I want that to equal the straight line, which is minus 2x plus 7. Okay, so let's just move this all over to one side by adding 2x to both sides, minusing 7 to get 16 equals 0, and then let's verify that x equals minus 4 is a solution, and we can do that by subbing in minus 4 and hoping that we get 0. And then of course, because we're verifying, we're allowed to use the answer, which is minus 4, to verify, as opposed to actually having to solve this equation and showing that it's minus 4. So that gives us minus 64, this gives us plus 48 and plus 16, which equals 0, and therefore we can say therefore x equals minus 4 is an intersection point of the two equations, or the two curves, or the one curve and one straight line of this and this. And just to finish off, I mean, what we could do is we could have subbed in minus 4 into here and subbed it into here, and if we get the same y value, then we know they intersect at the same point. That's another way of solving this question. But also it's important, you do need a conclusionary point. Okay, there is a mark for the conclusion, so you can't just leave it at at that point there, you must write this conclusion here. Therefore, x equals minus 4 is an intersection point of the two. Something along those lines. Okay, let's move on. Okay, now it says that the finite region R is shown. We need to use algebraic integration to show that the area is 108. Okay, so the first thing we're going to do, let's draw down the sort of limits of where we're going to be integrating. So we need a straight line down there and a straight line down there. Now this is x equals 2, because we know the a coordinate is 2, and this is x equals minus 4. So if we are going to integrate this curve between these two limits, we are going to get all of this region here underneath the curve. So we're going to get all of that, and we're going to get all of this as well. So just everything underneath the curve. Okay. Now obviously we don't want all of this yellow area. We just want the grey bit. But you can see that this shape that we have underneath the grey bit, this yellow is a trapezium. Okay, so let me outline the trapezium. Right there, that is vertical part there, so it's not a triangle. That's maybe the biggest mistake we can make here. This is actually a trapezium. So let's call it T for trapezium. Okay, so let's integrate first, and then we work out the trapezium, then we subtract the trapezium, and that will give us R. Okay, so part C, we are integrating between those two limits, which we said was 2 and minus 4, and the curve that we're integrating is x cubed minus 14x plus 23. And we're doing that with respect to x. Okay, great. So let's integrate. So we up the power by 1, then divide by the new power. Up the power by 1, and then divide by the new power. And then we up the power by 1, and divide by the new power. Okay. And that's between 2 and minus 4. We can simplify this. We don't need to divide by 1. No need to write to the power 1 there. 14 divided by 2 is 7, so we can just put a 7 in there instead, and that is good to go. Okay, we want to show our working here, so we're going to sub in each of these values individually. So we're going to do 2 to the power 4. Whoops. Still getting used to the calculator. 2 to the power 4, and then we're going to be then we're going to be dividing that by 4, and then we're going to be subtracting 7 times by 2 squared, and then we're going to be adding 23 times by 2. Okay, and that's going to be our upper limit, and we're going to get 22. So we'll write that down. So that equals 22. Okay, so lower limit, we're going to do, in fact, maybe a quicker way of doing this, minus 4 equals, and then we're just going to use the answer button. So we're going to say answer button to the power 4 over 4 minus 7 times answer squared plus 23 times answer, and because the answer is all minus 4, that should give us exactly what we need, and it's minus 140. Okay, so overall, by algebraic integration, that is going to be 162. Okay, right, let's bag that up. And now we need to work out the trapezium. Now the formula for trapezium is a half of the two parallel sides added together multiplied by the gap between them, h. So let's go and investigate. Okay. So the gap between the two parallel sides are these vertical ones. The gap between them is 6 because it goes from minus 4 to 2. What we need to do now is find the y coordinates of B and of A. Okay, so both B and A are on the line, of course, y is equal to minus 2x plus 7. So for us to find B, then we just need to sub in -4 into this. So we would get y is equal to -2 times -4 plus 7, which is equal to 8 plus 7, which is 15. So the y coordinate is 15, which means this height over here is 15. And now for a, we need to sub into the same line, because again, a is on that line, but the ax coordinate is 2. So we just sub in 2, which gives us -4 plus 7, which is equal to 3. So this height over here is 3. Okay, so we've got everything we need then to work out the trapezium. We've got 15 and 3 are the parallel sides, and 6 is the gap between them. Okay, so a half of 15 and 3 are the parallel sides, and 6 is the gap between them. So that's 18, halved is 9, 9 times 6 is 54. So that's the trapezium. So the overall region R is going to be the curved area under the curve minus the trapezium, which is equal to 108 for our final answer. Perfect. Okay, question 9. We've got log rules for 5 marks. Now, I think this is actually quite challenging, and I wouldn't be downhearted if you're not sure what to do here. I think it's possibly. I think it's really tricky, really tricky. Anyway, let's get into it. So, the trick here is to know your log rules. That's going to be really helpful. So let me just write out the ones which are really important to know, and that is that log AB is equal to log A plus log B. Log of A over B is equal to log A minus log B. Log of A to the X is equal to X log A. And log A of A is equal to 1. That one could be useful. I don't think it's useful in this particular question. But anyway, these are the big ones that you really need to know. So let me just box those up, and we'll keep those on the side there. Okay. Right, so A. So log A of 256. So the trick is to write 256 equal to either 16 to the power of something, or in this case 25 to the power of something. Because we have 16 and 25, those are the ones that we know. Now 25 is 5 squared, and 256 doesn't have any factors of 5, so it's definitely going to be this one. And in fact, this one, if you know your squares, is equal to 16 squared. So we can say this is equal to log base A of 16 squared. And then we can use rule number 3. Let me just number them. 1, 2, 3. Yeah, so rule number 3, and that is going to tell us that this is equal to 2 log A of 16. So that's equal to, well, log A of 16 we know is P, so this is just 2 to the P. Sorry, just 2P. Okay, great. Right, B, log A of 100. Okay, well, we need to split up 100 into its factors. It has a factor of 25, which is really helpful. So we're going to say log A of 100 is equal to log A of 4 times by 25. So 25 is nice and easy because it's literally right there. But what about 4? 4 is equal to 16 to the power of what? Well, this works. 4 is equal to the square root of 16. So 4 is equal to 16 to the half. So we're going to use that. Okay, so we're going to use log rule 1 here to split this up, like so. And then we're going to swap out this 4 for 16 to the half. So this 4 here, we're going to swap this out for 16 to the power of a half. And then we're going to use rule 3. to bring that half down. So we get 1/2 log a of 16 plus log a of 25. And now this allows us to just write them in terms of p and q now, because log a 16 is p and log a 25 is q. So we're going to get 1/2 of p plus q. Brilliant. Okay, and then on to part C. Okay, wow, this one looks a lot trickier. So log a of 80 multiplied by log a of 3.2. Okay, so first thing we can do is let's rewrite it as, again, factors. So 80 has a factor of 16 because 80 is 5 times 16. So we can say log a of 5 times 16. 3.2. That's not obvious, but 3.2 is the same as 32 over 10, which is the same as 16 over 5. So written like that, we can now see the connection to 16 and 25. So I could write that as log a of 16 over 5. Okay, great. So let's just scroll down now. And let's use some of these log rules. So for the first one, we've got them times together inside, so we're going to use log rule 1, and we're going to say this is log a of 5 plus log a of 16. And we'll keep that in brackets because we're going to then multiply that by this one, which we're going to use log rule 2, and we're going to say this is log a of 16 minus log a of 5. Again, keep it in brackets like so. Okay, now 16, that's perfect. 16 works great. That's just directly, we know that that is p. But the other ones, 5, we need to use this method again. So 5 is equal to, it's obviously not equal to 16 to something, but it is equal to 25 to the power of something. And what is that something? That is to the power of a half, because it's the square root. So we can swap out the 5s for 25 to the half. Okay, so log a of 25 to the half plus log a 16 times by log a 16 minus log a to the 25 to the half. And this allows us then to use log rule 3, which you can just see at the top there. It means we can bring the power down. So we get half of log a 25 plus log a 16 times by log a 16 minus a half log a 25. Okay, and now we can just swap them out directly because log a 25 was q and log a 16 was p. So it's a half q plus p times by p minus a half q, which happens to be difference of two squares. So we could write this as p squared minus a quarter q squared if we wanted to. Wow, I cannot believe that that is worth such few marks. I think that's a really tricky question. If you got that right, well done. Yeah, only 5 marks. Crazy. Okay. Question 10, got a circle and it shows that we know what P is. We've got the coordinate of P, and that's the centre of the circle. And we've also got the coordinate of Q, and that just lies on the circle. It says K is positive constant, the line L is tangent to C at Q, and we know the gradient of line L. Okay, so this line here we know has a gradient of -2, so that's going to be helpful. And then straight off the bat we know now that because of the tangent radius property, that those are at right angles. So a radius to a point Q, or any point, and its tangent at that point is always at 90 degrees. So we know that the green line has a gradient of the negative reciprocal, because they're perpendicular, 90 degrees. So that would be a half, because these two gradients must times to make -1, because they're perpendicular. Okay, so let's use that then, because we have got the coordinates of PQ and we know what the gradient is. Okay, so how do we work out the gradient? Well, first off, we know it is equal to a half, but the gradient formula is m is equal to y2 minus y1 over x2 minus x1. So let's call q the second coordinate. So y2 will be k squared minus 2k. And then we are subtracting y1, which is the y coordinate of p. And then we're going all over the difference in x, so the x coordinate of q minus the x coordinate of p, which is -1. Okay, great. Let's simplify this a little bit. So on top we've got a k squared, we've got a minus 2k, and then minus a k, so that's minus 3k. And then we've got a minus 8 here, so that's minus 8. And then all over 3 minus minus 1 is 4. Multiply both sides by 4, so half times by 4 is 2. So we get 2 there is equal to k squared minus 3k minus 8. And then set it equal to 0 gives us k squared minus 3k minus the 2 to both sides gives us minus 10 is equal to 0. And that is exactly what we are trying to prove for part A. Okay, so part B, it says hence find an equation for C. So the first thing we want to do is solve this quadratic, which we can do just nice and easily by factorising. Two numbers at times to make minus 10 and add to make minus 3 are minus 5 and plus 2. So k is equal to 5 or k is equal to minus 2. But it does say here nice and clearly that k is a positive constant. So this is going to be our value for k, and we're going to reject this one. Okay, so if k is 5, then we now know the centre, don't we? Because the centre is at P, and P has these coordinates. So the centre P is at the coordinates -1, and then k plus 8 is 5 plus 8, which is 13. Okay, great. And now we also know what q is, because q has these coordinates 3 and then k squared minus 2k. Well, if k is 5, then k squared is 25 minus 2 times 5 is 10, so 25 minus 10 is 15. Okay, great. So now what we can do is we can work out the radius, because of course the radius is just the distance between PQ. And in order to work out the distance, we just do the difference in the x coordinates squared plus the difference in the y coordinates squared, and then square root the whole thing. Okay, so the difference in the x's, so it's -1, -3. The difference in the y's is 13 minus 15 squared. So this gives us, that's 4 squared, so that's 16. And this one here will be, well, that minus 4 squared is still 16, and this will be minus 2 squared, which is 4. Okay, so the radius is root 20. Okay, now the equation for a circle is x minus a squared plus y minus b squared is equal to r squared, where a and b are the centre coordinates and r is the radius. So we know what the centre is. The x coordinate is -1, so it's x minus -1, which is the same as x plus 1. and for the y, the centre is 13, so it's just y minus 13. And then the radius is root 20, so we want the radius squared, so that's just 20. And there you go, that is the equation for the circle. Sorted. Brilliant. Question 11. The prices of 2 precious metals are being monitored. Okay, great. Where T is the number of months. Okay, so it's a good idea to always highlight the units, and of course this is in pounds as well. And this is in pounds. Okay, and again T is the number of months. Okay, so it's given that VB is equal to 2VA when T is equal to 0. Find the value of P. Okay, well, when T is equal to 0, we get that VA is equal to, well, if T is 0, then this power here is 0, and e to the 0 is just 1, so we end up with 100 plus 20, which is 120. Now VB, when T is 0, again, this power will be 0, so e to the 0 is 1, so we'll just have p times 1, which is just p. And if we have that VB is equal to 2VA, then this tells us that P is equal to 2 lots of 120. So P is equal to 240. Okay, great. It says when T is equal to capital T, the rate of increase. Okay, so that's the rate of increase in the price of metal. The price per gram of metal A was equal to the rate of decrease in price per gram of metal B. Find the value of T. Give your answer to 1 decimal place. That is really interesting. Not seen a question like this before. Well, the key point here is the word rate. Okay, so that means that we're not setting the two values equal to each other. We need to set their derivatives equal to each other. Okay, so part B, like as I said, we need to work out the rate of increase and decrease, so we need to differentiate them. So dVA by dt is equal to, well, 100 is constant, so that differentiates to 0. Hopefully we know that if we have e to the kx, that differentiates to k e to the kx. So by that logic, if we differentiate with respect to t, this is going to differentiate to the 0.04 is going to come down and multiply by the 20. So it's 20 times by 0.04 and then e to the 0.04. Okay, t. Okay, great. So let's simplify that. This will be 0.8 e to the 0.04 t, like so. And then at t is equal to capital T, we will get the derivative will equal 0.8 e to the 0.04 capital T. Okay, let's do the same now for the other one, which is actually 240 e to the minus 0.02 t. Let's differentiate that, and again the k part of the exponential input here will come down and multiply, so it'll be 240 multiplied by minus 0.02 e to the minus 0.02 t, which we can tidy up to get minus 4.8 e to the minus 0.02 t, and then at this special point where t equals capital T, we get the derivative of this one will equal minus 0.48, the minus 4.8 e to the minus 0.02 capital T. Okay. Okay, great. So now we're told that at this particular time, the rate of, let's just check that again. Yeah, the rate of increase of the first one, so that's the rate of increase, is equal to the rate of decrease of the other one. Now, what we're going to do is we're going to set the two values equal to each other, but we're going to ignore the negative here, because what the negative does is it just tells us that it's decreasing. Okay, but the question says the rate of increase is equal to the rate of decrease. So the fact that one's negative and one's positive doesn't really matter, because we're comparing the rates, like how quickly this is happening. So we need like the magnitude of this one and the magnitude of that one are the same. So all that negative does is tell us it's a decrease, and the fact this is positive just tells us an increase, but we want the rates to be the same, so we just need to take the magnitude of each and set those equal to each other. Okay, so what we're going to do next is we're going to divide both sides by 0.8, and then we're going to divide both sides by e to the minus 0.2t. So let's first off divide both sides by 0.8. How many 0.8s fit into there? Well, it's 6. Like that. And then we're going to divide both sides by e to the minus 0.02t, which gives us 6 over there. And then we can use our indices rules, because we are doing an e divided by an e, so we just subtract the powers. And subtracting these powers gives us 0.06t, because we're subtracting minus 0.02, so that makes a total of 0.06. Then we can take the natural logarithm of both sides, which cancels out the e, because taking the natural logarithm of both sides is the inverse of e to the power something. And then we can divide through by that 0.06 to get our final answer here, which we can do on our calculator. So it's ln of 6, and that is over 0.06. And we get this. Now we need to check the units before we confirm our answer, but this looks like 29.86. Let's just go up and check to see what the units are. It does say give it to 1 decimal place, okay. So we need to round, and t is the number of months. And actually it just says the value of t, so we don't actually care about the units, because it just says the value of t, so it's not asking for literally like the time or the number of months, it's just saying the value of t. So t has an approximate value to 1 decimal place of 29.9. Final answer. Done. Question 12, and we've got some differentiation modelling, it looks like. All of the information is on the diagram, but it says show according to the model that the perimeter of the swimming pool is given as this. Okay, so this is a classic question where you are given the surface area in which you can form an equation in terms of x and y. You also need to form an equation for the perimeter in terms of x and y, and then you can eliminate y to get the perimeter just in terms of x. So let's start by working out a formula for the area. Well, this part is clearly just x times y, and because this is a quarter circle, it means that this distance here is the same as that distance there, which is x. And it says that the two rectangles both have length x and width y, so this is also xy, and the area of a circle is pi r squared, so it's pi, and the radius is x, but it's a quarter circle, so we're going to divide that by 4. Okay, so that gives us the area of the surface area. So we're going to say area is equal to, there were two xy's and there was a quarter pi x squared, and we're told that's equal to 100. Okay, great. So now we can rearrange that for y, because y is the variable we want to eliminate, because remember we want the equation for the perimeter in terms of x. So let's just do that now. 2xy is equal to 100 minus a quarter pi x squared. And then therefore y is equal to, divide both sides by 2x, or divide 100 by 2 gives us 50, so it would be 50 over x. And this one dividing by 2 will be 1/8, and that will be pi, and then dividing by x gives us just x. Okay, so that is an expression for y in terms of x, which is super helpful. Okay, now let's go up again and let's get an expression for the perimeter this time. So we know that this is x, and we know this is y, and this is y, and this is y, that's x, that's y, and then this quarter arc will be, the circumference is 2 pi r, but we need to divide that by 4, so we get a half pi r. So that is all of the perimeter. So we need to add all of them up. So how many y's do we have? We have 1, 2, 3. We've got 4 y's. We've got 2 x's, and we've got this a half pi x. Okay, great. So the let's do it over here. The perimeter is equal to, it was 4 y's, it was 2 x's, and it was a half pi x. Okay, so all we need to do now is just substitute the y, which we have down here. So we can say p is equal to 4 lots of y. So timesing this by 4 gives me 200 over x. Timesing that by 4 gives me minus a half pi x, and then we've got 2x, and we've got this a half pi x. Okay, great. So we can see here that these are going to cancel, so that's minus a half pi x and plus a half pi x cancel out perfectly. So we are left with those two terms, and just double checking, yes, that's exactly what they want. So that is 2x plus 200 over x for our final answer for the perimeter. Great. Okay, part B, it says use calculus to find the value of x for which p has a stationary value. So stationary value means the derivative is equal to 0. So we're going to take the perimeter and we're going to differentiate it for part B. Now the first thing we're going to do is we're going to write it as powers of x. So this is 2x to the 1, and because the x is on the bottom there, that means it is 200x to the minus 1. That's going to allow us to differentiate nice and easily. So dp by dx, the 1's going to come down times by the 2 to give us just 2x, and we're going to drop the power down by 1 to make 0. Now x to the 0 is just 1, times it by 1, of course we don't need to bother, so it's just 2. Minus 1 is going to times by the 200 to get minus 200x, and then we're going to drop the power down by 1. And stationary points are found when the derivative equals 0, so we're going to set that equal to 0. So we're going to say that 2 is equal to, so this is negative 200x to the minus 2, so we're going to move it to the other side. It's become positive 200x to the minus 2. And x to the minus 2 we can write as dividing by x squared, like so. We can then times both sides by x squared to get this. We can divide by 2, and that gives us that x is equal to plus minus 10. Now what is x? Well, x of course is this distance here. so therefore it must be positive. So the value of x that we're looking for is the positive 1. So our final answer is that x is equal to positive 10. Okay, great. Now, part C. Prove by further calculus that this value of x gives a minimum value. So minimum values occur when the second derivative is positive. So we need to differentiate again. So let's do that over here. So we're going to find the second derivative. So this is the first derivative right here, written out in nice easy form for us to differentiate. So we need to differentiate that. So 2 is constant, and constant terms differentiate to 0. Here, if we want to differentiate this, the minus 2 is going to come down times by the minus 200 to get 400, and then we're going to drop the power down by 1. Now we are interested in the second derivative at the point that we're investigating, which is when x is equal to 10. So this is going to give us 410 to the minus 3. Okay, so what is that? Well, 10 to the minus 3 is 1,000th. 400 times by 1,000th is 0.4. But most importantly, that is greater than 0. It's positive. And if the second derivative is positive, it means that we have a minimum. So we write therefore minimum point. Okay, great. At x equals 10. Okay, now it says access to the pool is by side AB, shown in figure 5. Given that AB must be at least 1 metre, determine according to the model whether the swimming pool with the minimum perimeter would be suitable. So what is AB? AB is Y. So we need to use that that expression that we had for Y, which is in that green box right there. Okay, so when x equals 10, AB is the Y value, which is going to be 50 over 10 minus 1/8 of pi times by 10. So that needs to go into our calculator to get that value. So that is 50 over 10 is just 5. So we'll do 5 minus 1/8 of pi. Okay, there's pi, times by 10. Okay, and we get that's equal to 1.073. Let's just double check the units. So those are all measured in meters. Okay, and it says here that it needs to be at least 1 meter. So that is greater than 1 meter. So I think we're good. So we can go here. We can say that this is meters, and it's greater than 1 meter, and then we can say therefore it is suitable. That should do the job. Question 10, show that this equation can be written as this. Now I have actually done this question before, and it is quite tricky. So I'm a little bit apprehensive about how I'm going to explain this, but let's just go with the flow and see how it works out. So we're going to multiply through by sine, would make sense here. That will give us 7 sine squared minus 4 cos theta sine theta is equal to 4. Okay, now first thing, I see that it's equal to 0. So nice low-hanging fruit is just to move everything to one side. Like so. Now next, whoops. There we go. Now next is all in terms of tan, of course. And we know that tan theta is equal to sine theta over cos theta. We've got a sine squared here and we've got a tan squared there, so it just makes sense here to be dividing by cos squared. And let's see what we get. So dividing by cos squared, like so, it's going to give us this. And it's going to give us this. And it's going to give us this. Now, sine squared over cos squared is tan squared. So it's going to give us 7 tan squared. And then we've got here cos over cos squared. Well, that's going to cancel. So it's just going to be sine over cos. Because we've got cos and we've got cos squared. So that's going to leave 1 cos on the bottom. Sine over cos is tan. So that's going to give us 4 tan theta, and then we're going to get this minus 4 over cos squared. Now if you're doing this and you're in year 13 and you've already done chapter 6 book 2, you'll be able to solve this so much easier, because this can be written as the reciprocal trig function sec squared, and there's an identity that links sec squared and tan squared, so it'll make it so much easier. But without that knowledge, we're going to have to instead do some further manipulating. Now, what I can see here is we've got this and this. Okay, now those are exactly the same, which is good. And we've got too many tan squareds here. We've actually got an extra 4 tan squared, haven't we? So what we can do is we can write this as 3 tan squared is the 3 tan squared that we want, and we like having this 4 tan theta here as well, but we're going to have an extra 4 tan squared, and we've got this minus horrible thing 4 over cos squared, like that. Okay, so this is good. So now we've got these guys, which are exactly kind of what we want. We just have to somehow turn this expression here into this, and then we'll be good to go. Okay, so whenever you want to turn 2 things kind of into one, or if we have 2 fractions into one, you're going to want to make a common denominator. So you want to turn both of these 2 things into a fraction and then give them the same common denominator. Well, we can actually do that relatively straightforward, because we know that tan squared is of course sine squared over cos squared. So we can write this as 4 sine squared theta over cos squared theta, like so. And now they've got the same denominator, so it means that we can write them as a single fraction, which is great. So this becomes 4 sine theta minus 4 all over cos squared theta. Okay, now what we can do, we can take out a factor of 4, and in fact I'm actually going to take out a factor of minus 4 here, because that will change the sign of each of these, so it will become 1 minus sine squared. Okay, just double check that that makes sense. But yes, taking out a minus 4 will change the sign of each of them, so the minus 4 will become just 1, and the 4 sine squared will become minus sine squared. And why have I done that? Because as we know, sine squared theta plus cos squared theta equals 1, which means that if we want to work out cos squared, it's the same as 1 minus sine squared. 1 minus sine squared, like so. So 1 minus sine squared there, which is cos squared. And of course, cos squared divided by cos squared is just 1. So that divided by that will make 1. And therefore we'll get 3 tan squared minus 4 tan, and then just minus 4 times 1 is just minus 4, and that equals 0. Okay, bit of a beast, that one, but we got there in the end. Okay. And then it says, hence solve for x between 0 and 360. So let's see the comparison. Well, in fact, it's exactly the same, isn't it? So this equation here is exactly the same as this equation. The only difference is we've swapped out theta for x. So if we want to solve this yellow one at the top, we can in fact instead just solve this one instead, because it's the exact same equation. So we need to solve that equation, just swap the theta for x, and make sure we remember that the range is between 0 and 360. So part B, we are solving 3 tan squared x minus 4 tan x minus 4 is equal to 0 between 0 and 360. Okay, so this is a quadratic which we can factorize. We don't actually have any marks for factorizing, so we could just use our calculator to solve this. But just quickly doing it, so this will give us so minus minus 2 and plus 2. I think that does the job. No, it doesn't. That should be a plus 2 and that one should be a minus 2. That does the job. Yes, it does. Yes, that works. Great. Okay, so tan x is equal to minus 2 over 3 and tan x is equal to 2. Again, you don't actually get marks for factorising this, so you could just use your calculator, quadratic solver on your calculator to get these values. Okay, so now x is equal to inverse tan of minus 2 over 3. Now x is equal to inverse tan of 2. So let's now use our calculator, making sure we're in degree mode, and we're going to go for inverse tan of minus 2 over 3 first, and that's going to give us minus 33.7. Okay, now as soon as you've done inverse tan, the second solution for tan is for tan. The second solution is 180 plus the first. For sine, it's 180 minus the first, and for cos, it is 360 minus the first. Always good to remember those because it makes it so much easier solving trig equations. So as soon as you do inverse of a trig equation, you then find the second solution. So for tan, you just add 180. Okay, so that is the next solution along, which is 146.3. And then, when you have your first two, you can add or subtract 360 either way. Now, because the range is between 0 and 360, I can actually add 360 to this first one here. And that will give me another solution which is in the range. Okay, so just remind ourselves, that one was this. So if I add 360 to that, we should get another solution, and that is also in the range. So that is 326.3. Okay, so these are the two that work. And now we can move on to that second equation, which is that tan x equals 2. So we can then go to our calculator and do tan to the minus 1 of 2. And we get 63.4. So we'll write that one down. So we'll get that x is also equal to 63.4. All of these are degrees, of course. And then we can just simply add 180 to that to get another solution, 243.4. And then we can't find any more solutions, because if we add 1 or 360 to either of these, we'll go outside of the range, of course. So those are the final answers. Okay, question C. Right, it says, hence find the smallest solution of the equation sine of 4 alpha, blah, 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 all in terms of 4 alpha equals 4 in this range. Okay, now this is going to take a lot of explaining, so buckle up. For 1 mark as well, but anyway. Now what we've done is we've just solved this equation for x. And it's asking us now to solve this equation, which is absolutely identical, apart from x has been swapped out for 4 alpha. So the solutions to this equation will be exactly the same as the solutions for 4 alpha of this equation. So when we have x equals, so all these solutions down here that are x equals, this one, the new equation is going to be exactly the same, but it'll be 4 alpha equals. So we'll put them in order, like so. Okay. Now, what happens with trig equations is we have 4 solutions that are within the range between 0 and 360. Okay, those are the solutions for x, and now these happens to be the solutions for 4 alpha. Okay, so these are all bounded between 0 and 360, but these will repeat every 360 degrees. All we need to do is just add 360 to each one of them, and we'll get the next set. Okay, now where are the solutions that we are interested in? They occur in this range here. Now whenever we get a range, but the input is like 4 times alpha or 2 alpha or 2x, we want to multiply the range to get it in terms of, in this case, 4 alpha. So we're going to times this by 4. Okay. So what we're interested in is so 720 multiplied by 4 is this. Again, I'll tell you, this explanation is going to take a while, but this is the only way I can really explain it, by actually, explaining it in full detail. And then we're going to also multiply the end of the range, which was 1080, multiply that by 4, so we get that. Okay. Right. So we want solutions for 4 alpha to be within this interval here. And what we can do is we can add 360 as many times as we want to each of these solutions. Now the first solution, which is going to be the smallest solution, is going to be this one, obviously because it's first and it's the smallest. So how many 360s do I have to add to this in order to get it inside that range? Well, 720 times by 4 was the lower bound of the range. So how many 360s is that? That's 8 360s. So we need to add on 8 360s. Okay, so if we take this, so we can say 4 alpha is also equal to this plus 8 lots of 360s. And that should fall inside the range that we're looking at. So if we do 63.4, add on 8 times 360, this should fall inside the range. Yeah, perfect. In fact, of course, it is just simply the lower bound of the range plus the 63.4. So we get that there is a solution in that range. Okay, but of course we want to find alpha, so now is the time that we can divide by 4. it's always the last thing you do, which is divide by whatever the coefficient is of the variable you're looking for. And then again, we've got to press this format decimal button. It wants it to one decimal place, so the answer is 735.9 for what is, I think, the most beastly 1 mark I've perhaps ever seen. Question 14. Prove using algebra that n squared plus 5 is even for all n natural. Lovely. Love a question which is just so simple, loads of writing, and it just is what it is. Okay, so normally to solve a question like this, we consider two cases. We consider n being even, which implies that n would equal 2k, where k itself is a natural number. So even numbers can always be written as 2 times by another natural number. Okay, so if that was the case, then n squared plus 5n would equal 2k squared plus 5 lots of 2k, which is equal to, well, 2k all squared is 4k squared, because 2k times 2k is 4k squared, plus 10k, and we could write that each of these have a factor of 2. So we can say that is 2 lots of 2k squared plus 5k, and then we can say hence even, because it has a factor of 2. Okay, great. Now the other option, of course, is that if n was odd. If that's the case, then n would equal 2k plus 1. Because all odd numbers can be written as 2 times a natural number plus 1. Okay, so next we just need to see what that would give us. So we would be doing 2k plus 1 squared plus 5 lots of 2k plus 1. Great. Now 2k plus 1 is not as obvious, 2k plus 1 squared, to expand, so I'll just do it on the side here. We'll get 4k squared, we'll get plus 2k, we'll get plus 2k, and finally we'll get plus 1. So this will be 4k squared plus 4k plus 1, and then expanding this bracket is going to give us 10k plus 5. Collect up like terms to get 14k and plus 6, and then we can write that as, again, having a factor of 2 by just taking out a factor of 2, and then we can say hence even. And finally we need a conclusion restatement, so we can say that it has been proven n squared plus 5n is even for n even and n odd, therefore for all n natural. Perfect. Thanks for watching, and subscribe for more. See you in the next one. Bye for now.